All right, Algebra 1. Today we are going to move into 9.3, solving quadratics now by graphing. So we kind of learned how to graph quadratics already. Now we're going to, the key word here with today's lesson is we're going to solve them now. So we're going to solve using a graph. So if you recall from our section on lines that we did a while back, if you had a line, right, the solution to the line is where the line crosses the x-axis. All right, so for today, we're going to look at where a quadratic equation, which is what we've been focusing on, where does that cross our x-axis? So say I have something that looks like this. What are these points here where it crosses the x-axis? That's going to be how you solve a quadratic. Okay, so that's what we're going to focus on today. So here are some possibilities with this. If the solution happens where we cross x, notice the first one here. This parabola is flipped upside down. Yes, that doesn't really matter because it crosses the x and it crosses in two places. So there's two solutions there for that particular case. But then we can also have a parabola that comes down or comes up from below, doesn't matter which way, and touches the x-axis here. Okay, and then turns around and goes back. So it doesn't technically go through, but we say it has a double root or one solution that is a double solution that happens at the same point. Okay, and I'll show you why it's considered a double root soon. By the way, this relates to all of your perfect square trinomials, going back a couple of lessons from the last chapter. And then we have the possibility of it never touching the x-axis, and in that case we have no real solutions. There's actually a solution in the imaginary number system, which we will get into in Algebra 2 in a couple of years. Okay, so here we go. Let's just jump right into an example. So example 1, solving by graphing. This is one that has two roots. Okay, so first of all, what I would encourage you to do is to find your axis of symmetry. So you're going to use your negative b over 2a. You're going to plug it back in for I don't know why it says for y. It's for x, right? We're going to plug it back in for x to get our y. Then we're going to find our y-intercept, and then we're going to use symmetry to graph this. Okay, so let's just take a look at what happens when we do that. Since I know that my y-intercept happens at a big number 18, I'm going to make this graph go up by perhaps 3s. So 3, 6, 9, 12, 15, 18, 21. So I'm going by 3s there, so I'm labeling my graph because I know that this thing is going to cross my y-axis at 18. My y-intercept's at 18. I know that without doing any math. So I know that this point here is on the graph. Okay, so now what I have to do is let's find my axis of symmetry. So if I do negative b, remember here, you guys, just a quick reminder that negative b here in this case, that's negative 3. Two negatives together always make a positive, right? So negative 3 over 2 times negative 1. A in this case is a negative. We can assume that it's a 1 even though the 1's not there. Okay, so what we end up with here is positive 3 over negative 2. Well, that's the same thing as negative 1 and 1/2. Okay, so if I'm going by 3s, actually maybe on my x direction I might change this and just go by 1s. So let's just say this is 1, negative 1, sorry, negative 2, negative 3, etc. Negative 1.5 would be right here. Okay, so there's your axis of symmetry. We just found that, negative 1.5. Now what we need to do is we need to plug that negative 1.5 back in. Okay, so be careful of your algebra here. We have negative, and then we have parentheses, negative 3 over 2. By the way, 3 over negative 2 could be written as negative, 3/2. Same thing, doesn't matter. Squared, okay, minus 3 times negative 3 over 2 plus 18. Okay, so if I do this here, the algebra is this. I'm going to take my 3 to the second power there. This is negative, but it's going to turn positive here on the inside. So negative 3 squared is just 9. 2 squared is 4. but I have that negative on the outside, so this is a negative. So negative 9/4. And then here I have a negative 3 times negative 3 halves. Negative 3 times negative 3 is actually a positive 9 over 2. Okay, because imagine this is like negative 3 over 1. Okay, we're multiplying there. And then we have plus 18. All right, so now I got to make a common denominator, right? So if this is 4, I want this to be 4. So let's do that. This is negative 9/4 plus, if this turns to a 4, that would have to multiply both numerator and denominator by 2. So this becomes 18 plus 18. Negative 9 plus 18 is actually just 9, right? Positive 9, so I have 9/4 plus 18. All right, so that's essentially 2 1/4 plus 18, so that would be 20 1/4. So when I plug in my negative 1 1/2, I get 20 1/4. And that math is kind of ugly, and I wish they would have chosen a better example here with less fractions, but you're going to have to do it, so it's good that we just practice that. So at 20 1/4, at negative 1 1/2, and I plug negative 1 1/2 in, I get 20 1/4, which is somewhere up in here. Okay, so that's my vertex. All right, and so I know over here I also have a point here. Okay, so I kind of have this thing happening, right? So I want to see where the whole thing here is to solve this by graphing. So I want to see where this graph crosses this x-axis. So I need to plug some more points in. Okay, so we can kind of guess here what points we need to plug in. This was 0. So if we plug in, let's just see what happens if we plugged in a positive 1. Okay, at positive 1, what happens? So in order to do that, you're going to need a little bit of room for this. You're going to plug a 1 into the equation. So we have negative 1 squared minus 3 times 1 plus 18. Okay, so negative 1 squared is just going to be, that's 1 squared, which is 1, and then you apply the negative. So it's negative 1 minus 3 plus 18, which gives me negative 4 plus 18, which is equal to 14. So at 1, I'm at 14. Okay, so I'm up here. Okay, so I know this is not going down very fast, so perhaps what I do now is I plug in something like a 3. Okay, so what happens when I plug a 3 in? If I plug a 3 in, I get negative 3 squared minus 3 times 3, I'm just plugging it back into my equation, plus 18. 3 squared is 9, so I have a negative 9 minus 9 more, plus 18. Okay, so when I simplify this, negative 9 minus 9 is negative 18, plus 18, which is equal to 0. So at 3, that's exactly what I was looking for. At 3, I have a 0. Okay, notice this was 1, 2, 3, 4.5 spaces from my vertex. So I can go 4.5 this way. There's a half, 1, 2, 3, 4. So I know my other point's going to be over there. This is going to be at negative 4, negative 5, at negative 6. Okay, so my 2 zeros, which I found by graphing, the zeros are at x equals 3 and x equals negative 6. And that's how you find it. All right, so kind of getting you used to graphing here. All right, so let's just erase some of this. You can always pause the video or go backwards on the video if you need to see any of that again. But let's keep cruising. For 1b, it says to solve this by graphing. So I'm going to encourage you to try this one on your own. Okay, I don't think this one's going to be as ugly as the one before, but I don't remember off the top of my head. But let's just have you pause the video, try this one out. All right, guys, so here we go. Let's do this. So first, we're going to find our axis of symmetry. So the axis of symmetry here is going to be negative negative 4 over 2 times positive 1. Negative negative 4 is positive 4. 4 divided by 2 is just 2. So your axis of symmetry happens at 2. Okay, so at 2 we have symmetry. All right, so now I'm going to plug that back in to see where my vertex is. So if I do that, I get 2 squared, which is 4. 4 minus 4 times 2 is 8, plus 3 equals 0. Okay, 4 minus 4 is negative 4. Negative 4 plus 3 is negative 1. So at 2, I'm at -1. Okay, so 2, -1. There's your vertex. We know it's opening up. We also know another point, the y-intercept. That happens right here always. And in this particular case, that is at 3. So at 3, we have this. Okay, which means over here we also have a 0, because this distance here was 2 to the symmetry line, so this one would be 2 as well. All right, so when I connect this through, it appears as though my zeros happen at 1, x equals 1, and 3. But if you wanted to confirm that, what you could do is you could just plug those back in. Okay, so if you plug it in, you should get a 0. If I plug it in, so let's do 1 squared minus 4 times 1 plus 3, and see if that equals 0. So this is 1 minus 4, which is -3, plus 3, which is equal to 0. So 1 did work out. So since 1 works out, I know that the 3 must work out because of symmetry. But you can go ahead and plug a 3 in there to double check me. Okay, so 1 and 3 are what works. All right, and then example 2 here. For example 2, what they want you to do is they want you to, let's check this here. Yeah, we're good. Okay, so for example 2, the double roots, what they want us to do is they want us to graph this like anything else. So put it in standard form first. This will be x squared. I'm going to just move this 10x over. So I get x squared minus 10x plus 25 is equal to 0. Okay, so what they want us to do is just graph this. We know that we have a y-intercept at 25. Okay, we also know that the symmetry happens at -10 over 2 times 1, which is 10 over 2, which is equal to 5. So at 5 we have symmetry, which means I have a point over here as well. It's opening upward. Okay, so I know this kind of thing is happening. All right, so now what I got to do is I'm trying to figure out where it crosses the x-axis. So it makes sense to try to plug in the thing in between. So that would be a 5, right? So if I plug in the 5 that I got here, if I plug that back in, let's see what happens. So it will be 5 squared minus 10 times 5 plus 25. Okay, so 5 squared is 25. 25 minus 50 plus 25. 25 minus 50 is -25 plus 25, which is equal to 0. So when I plug that 5 in, I actually get 0 for y out. So I am right there. Okay, and that is my vertex. So whenever your vertex falls on your axis of symmetry, you know that that's a double root on the x-axis. That'll always be the case. So the answer here is 5. Okay, that is where the solution is. And if you wanted to check it, you could plug that back in and get a 0 like we did. But that's your final answer. Okay. 2b, what we need to do for this one is first put it in standard form, right? So I'm going to move everything. We don't want this to be negative, otherwise I'd move this way. So instead I'm going to move these guys over here to keep the x squared term positive, all right? So this becomes x squared plus 8x plus 16 is equal to 0. Okay, so I know that I have a y-intercept at 16, which is approximately there on my graph. So then what I could do for this is go ahead and find my axis of symmetry. So that would be -8 over 2 times 1, which is equal to -8 over 2, which is equal to -4. So at -4, I have symmetry, somewhere in there. Okay, and then I'm going to plug that back in. If I plug that back in, let's see what happens. By the way, we know this, since this happened at 16 here, we can go a distance of 4 the other way, so that would be at -6, 7, 8, -8. So at -8, we have this happening, okay, and we know it's opening upward, so it would be natural to plug back in our axis of symmetry, which is -4. So I plug the -4 back in. -4 squared plus 8 times negative 4 plus 16 equals 0. Negative 4 squared is 16. Okay, 16 plus, this is going to be minus 32 plus 16. That gives me negative 16 plus 16, which equals 0. So again, since I got a 0 there, that's going to be your point. That also has to be the root. So this is a double root that occurs at negative 4. Okay, because that's where it crosses the x-axis. And then I have to give you one at least that has a no solution. So this one will be a no solution. Let's just see what happens with this one. So for this one, we can move this 5 over. And when we do that, we get negative x squared minus 3x minus 5 is equal to 0. Okay, so to solve this guy, what I need to do is find my axis of symmetry. So my axis of symmetry is at negative 3 over 2 times negative 1, which is equal to 3 over negative 2, which is equal to negative 1.5. So at negative 1.5, I have symmetry. I also know that my x-axis was being crossed at negative 5. Okay, so I got to find my vertex, right? So if I find my vertex by plugging this back in, so I get negative 1. Let's keep it as an improper fraction. I'll show you why that's the easiest here in a second. So I'm using this guy instead of the simplified mixed fraction. Minus 3 times that guy again. Minus 5. Okay, so when I square this, the negative's on the outside, so it's going to be a negative. 3 squared is 9. 2 squared is 4. That's why I wanted to keep it in fraction form. So that's negative 9/4. And then I'm going to add this because it's a negative times a negative, so it's going to be plus 9 over 2 minus 5. Okay, so let's find the common denominator there, which would be 4. So this would be negative 9/4 plus 18/4, because I had to multiply this by 2 and this by 2 in order to get a common denominator of 4. Okay, and then minus 5. Okay, so negative 9 plus 18 gives me 9/4. 9/4 minus 5. If you turn this back now into a mixed number, that's the same thing as 2.25. So 2.25 minus 5. There's a couple of ways we could figure that out. We could either do this math like this, or I could have changed 5 into fourths. So if I did that, it would be 9/4 minus, if I put a 4 underneath that 5, I had to multiply that 1 by 4, so I have to do the same on the top, so it's this. So 9 minus 20 is the same thing as negative 11/4. Okay, so negative 4 goes into 11 2 times with 3 left over, so it's 2 3/4. So either way you do that's fine, but it's going to be negative. Okay, so when I plugged in my vertex, I got negative 2 3/4. Negative 2 3/4 is somewhere in here, and this thing is opening downward. Okay, so what I know now is that I don't need to keep going really. I can draw this rough sketch because I know that it's not going to cross my x. This is a no solution problem. And really you should say no real solution, because there actually is a solution to this, but not in the real number system. All right, guys, next time I'm going to show you how our factoring from last chapter plays into everything that we're doing here. So we'll make a bunch of connections, but hopefully this gets you started on your homework for 9.3.